In section 1.7, we'll look at inequalities, linear inequalities, three-part inequalities, quadratic inequalities, and finally rational inequalities. Let A, B, and C represent real numbers. If we have an inequality, A less than B, then I could add the C to both sides of the inequality, and it does not change the direction of the symbol. If A is less than B, and if C is greater than 0, then we can multiply both sides by C, and the direction of the inequality will not change as well. The third property is very important. If A is less than B, and if C is less than 0, or a negative number, if C is a negative number, then multiplying both sides by C will cause the direction of the inequality to switch. So if I'm multiplying or dividing by a negative, it will cause the direction of the inequality to switch directions. If C is positive, it doesn't do that. So be careful. If C is negative and you're multiplying both sides by a negative, you have to switch the direction of the sign. Same thing for dividing. If you're dividing by a negative, switch the direction of the sign. Let's look at example 1, part A. I want to solve 2x plus 5 is less than or equal to 17. First step is to isolate the x term. So let's subtract the 5 to both sides. This gives me 2x is less than or equal to 12. And I don't have to switch the direction of the sign because I subtracted both sides by a negative. I only switch the sign if I'm dividing by a negative. Now we can divide both sides by 2. And this gives us x is less than or equal to 6. This is our solution as an inequality. X is less than or equal to 6. I can also graph this on a number line. I can put the 0 here to represent the center of my number line, and the 6 is somewhere on the right. Let's put a closed circle because we know that x could be equal to 6, and we're going to shade all of the values of x that are less than 6. So that would be to the left of our number line here. So this is our graph. We have a closed circle because it includes 6. And it's pointing to the left because our arrow points to the left. All the values of x less than or equal to 6. Now we'll look at the interval notation. For the interval notation, I know this goes forever to the left. It goes to negative infinity. So I'm going to put a parentheses, negative infinity, and then it's going to go to 6. And we're going to put a square bracket around the 6. Now, why do I put a square bracket around the 6? Because it reaches 6 is included, so we use a square bracket around the 6. Now, infinities always uses a parentheses because we can never include the infinity in our solution. It can go forever to the left, but it will never reach infinity. It's not possible. So this is our interval notation. Again, the parentheses is always used for infinities, and the bracket is on the 6 because we can include the 6. Question 1, part B. Let's solve negative 3x plus 5 is greater than negative 7. First step is again to isolate the x. We'll subtract the 5 to both sides. This gives me negative 3x is greater than negative 12. And now I can divide both sides by negative 3. But remember, you have to switch the sign because we're dividing by a negative. So let's switch the direction of the sign. We have x is less than positive 4. Again, I switched the direction because we divided by that negative. Don't forget, it's very important. Now here is our inequality. X is less than 4. I want to also do the graph. I have a open circle at the 4. Now why is this open? Well, because we have x is less than 4. It's not included. There's no equal sign, so we don't include the 4. Now the arrow is still going to point to the left because all the values that are less than 4 are on the left. So I'm going to shade to the left. Now what is our interval notation? Well, it goes to the left forever, negative infinity, so I'm going to put a parentheses. Again, parentheses are always used for the infinity symbol, and it goes to the right 4, and I'm going to put another parentheses around the 4. Now how come this is not a square bracket? It's not a square bracket because this is an open circle. 4 is not included. If this was closed, I would be using a square bracket. But since it's open, make sure we use a parentheses. In example 2, we're solving another inequality. We have 4 minus 3x is less than or equal to 7 plus 2x. I want to give my solution in interval notation as well. So the first thing I want to do is I want to isolate the x. Let's start by subtracting the 4 to both sides, and this will get rid of that 4 on the left. This gives me negative 3x is less than or equal to 3 plus 2x. Now a good tip is to keep the x on the left side. If I subtract 2x, I will keep the x on the left side. Now why do I want the x on the left? It just makes my life a lot easier having the x on the left side because I can use the direction of the inequality to draw my graph. So I have negative 5x here is less than or equal to 3. Let's divide both sides by negative 5. Again, what happens when we divide by a negative, I gotta remember to switch the direction of the sign. So let's switch the direction. This is going to be x is greater than or equal to negative 3/5 now. So this is my solution as an inequality. Let's draw a picture. I have 0 here. Again, that's the center of our number line. And negative 3/5 is somewhere on the left. We're going to put a circle, and since this is equals, we'll shade it in. And I want to look at all the values of x that are greater than or equal to negative 3/5. That means everything to the right will be shaded. So here is our graph of the inequality. And now let's look at our interval notation. We're going to put a square bracket, negative 3/5, comma, infinity, then a parentheses. Now if you're having trouble with the interval notation, look at your picture. Negative 3/5 is on the left, and your arrow points forever to the right, so infinity should be on the right. Now I'm using a square bracket because we have a closed circle. And again, the infinity always has a parentheses because you can never reach infinity. You can approach it forever, but you can never reach it. So infinities always have a parentheses. And again, this is a square bracket because it's a closed circle, because there's an equal sign here. Example 3, if the revenue and cost of a certain product are given below, we have the revenue equals 4x, and the cost function equals 2x plus 1,000, where x is the number of units produced and sold, and what production level does R at least equals C. So in this case, we want to know when R is at least equal to C, so we want to set a situation where R is greater than or equal to C. That is what we're trying to solve. R greater than or equal to C means 4x is greater than or equal to 2x plus 1,000. Now I can solve this for x. Let's subtract 2x to both sides. We have 2x is greater than or equal to 1,000. Let's divide both sides by 2. x is greater than or equal to 500. What does this mean? Well, it means I have to sell at least 500 products to break even. That's what this thing means. I have to sell at least 500 products to break even, where the revenue is greater than or equal to the cost. Typically for an inequality, you want the x on the left side, and you're going to isolate the x on the left and solve the inequality. For a three-part inequality, it's a little bit different. I want x in the middle. It will be easier to solve if x stays in the middle for a three-part inequality. Notice here we have 5 plus 3x in the middle. Let's subtract 5 from all of the sides. When I'm doing an inequality, I have to subtract from all three sides. So let's subtract 5 from all three sides. We have negative 7 is less than 3x, and that's less than 15. Let's divide by 3 to all three parts. This simplifies to negative 7 over 3 is less than x, and that's less than 5. Now, how do we graph this? Well, we're going to do the number line just like before. We're going to have a 0 to denote the center of our number line. Negative 7/3 is on the left side, and it's going to be an open circle because there's no equal sign underneath. 5 is going to be on the right somewhere. Let's say it's here. And again, it's going to be an open circle because there's no equal sign underneath. Now, since x is between these two numbers, we're going to shade between. So that's a good way to remember. If x is between, shade between. Don't draw your arrows facing both to the left. What this is saying is x is between 5 and negative 7/3, so shade between those two. And since we do not have equal signs in our inequality, we're going to leave these as open circles. Now, what's my interval notation? My interval notation is going to be a parentheses negative 7/3, comma 5. Because it goes to the left negative 7/3, it's an open circle, so use the parentheses. It goes to the right to 5, again it's an open circle, so use the parentheses. So this is our solution as an interval notation. This is our solution as an inequality. And of course, this is our solution as a graph. Now let's look at quadratic inequalities. A quadratic inequality is an inequality that can be written in the form ax squared plus bx plus c is less than 0 for real numbers a, b, and c, with the leading coefficient a not being equal to 0. The symbol less than can be replaced with the symbol greater than, less than or equal, or greater than or equal. To solve quadratic inequalities, there are 3 steps. Step 1, solve the corresponding quadratic equation. Step 2, identify the intervals determined by the solutions of the equation. And then step 3, use a test value from each interval to determine which intervals form the solution set. Example 5, I have x squared minus x minus 12 is less than 0. Now the first thing I want to do is to find the zeros of this quadratic inequality. So I'm going to set this inequality with an equal symbol instead so I can find the zeros. That's step 1. Find those zeros. Now in order to solve this, we'll factor. This is x minus 4 times x plus 3 is equal to 0. From the diamond method, we have negative 12, negative 1. The two numbers are negative 4 and 3. Now this means x minus 4 is equal to 0, or x plus 3 equals 0. I could add 4 to both sides, and x equals 4 is one of our solutions. I could subtract 3 to both sides, and x equals 3 or negative 3 is another solution. In step 2, the two numbers, negative 3 and 4, divide the number line into 3 intervals. The expression x squared minus x minus 12 will take on a value that is either less than 0 or greater than 0 on each of these intervals. So now let's review. Remember, we solved for x squared minus x minus 12 is equal to 0, and we said x could be equal to negative 3 or x could be equal to 4. And when we look at our number line, we're going to put open circles at negative 3 and 4. Now, why is it open circles? Because we're trying to figure out when x squared minus x minus 12 is less than 0. So since this is a less than symbol, these are open circles. These are not included. This will cause our quadratic x squared minus x minus 12 to be exactly equal to 0. So any other place besides negative 3 and 4 has to either be less than 0 or greater than 0, because there's only two places on our graph that it's exactly equal to 0, at negative 3 and positive 4. So we have three intervals. To the left side of negative 3, the left side of negative 3, which is from negative infinity to negative 3, between negative 3 and 4, and to the right side of 4, or 4 to infinity. In step 3, let's choose a test value from each interval. Again, let's look at our number line. We know at x equals negative 3, we have an open circle. We know at x equals 4, we have another open circle. Now we want to satisfy the inequality x squared minus x minus 12 is less than 0. So I want to check some test points in our regions to see if this is true or not for that particular x value. So let's pick a good number to the left of negative 3. You can pick whatever you want. I'm going to test x equals negative 4 because that's to the left of negative 3 in our first region or interval. Let's test another number. What's a good number between negative 3 and 4? I'm going to test x equals 0. Again, you can pick whatever you want as long as it's between negative 3 and 4. Then we're going to pick another interval. Something to the right of 4, I'm going to pick x equals 5. Now I could easily pick x equals 100 if I wanted to, as long as it's to the right of number 4. Now we can plug it into our inequality. If it is true, that means that interval contains our solution. So let's test x equals negative 4. We're going to plug it into our inequality. We have negative 4 squared minus negative 4 minus 12. Is that less than 0? Well, this is 16 plus 4 minus 12. Is that less than 0? I have 8. Is that less than 0? No, it's not. This is false. This is false. So we know x equals negative 4 does not work. So we'll test another interval. Let's test x equals 0. We have 0 squared minus 0 minus 12. Is that less than 0? Well, negative 12 is less than 0. This is true. Since this is true, that means the region between negative 3 and 4 is a solution to our inequality. So I'm going to shade between negative 3 and 4. Anything that I choose between negative 3 and 4 will satisfy my inequality. It will be true. Now we're going to test the number to the right of 4. So let's test 5. I have 5 squared minus 5 minus 12. Is that less than 0? This is 25 minus 5 minus 12. Is that less than 0? 8 is not less than 0. The left side simplifies as 8, and that's not less than 0. That is false. So that means the number to the right of 4 does not contain any solutions to our inequality. So our solution is just from -3 to 4, but what's our answer as an interval notation? Our answer is going to be parentheses -3 to 4 parentheses. This is our solution. Anything from -3 to 4 is going to satisfy the equation x squared minus x minus 12 being less than 0. Example 6, let's solve 2x squared plus 5x minus 12 is greater than or equal to 0. Again, I want to find the zeros. So let's set 2x squared plus 5x minus 12 being equal to 0 first so we can find our intervals on our number line. This is going to be the AC method. Let's multiply 2 times -12, -24, and 5 on the bottom. What's the two numbers that work? Well, it's going to be 8 and 3. It'll be a -3. So this is 2x squared plus 8x minus 3x minus 12 is equal to 0. I could do factor by grouping now. I can take out a 2x to the front. I have x plus 4. And we'll factor out a -3. Again, we have x plus 4. This factors as x plus 4 times 2x minus 3 equals 0. So that means x could be equal to -4, or x could be equal to 3 over 2. Again, set each of these factors equal to 0 and find your intervals. Now we'll go to our number line, and we're going to put -4 on the number line and 3 over 2 on the number line. Since this is greater than or equal to 0, I'm going to have to fill in -4 and 3 over 2. These are going to be closed circles because these cause our inequality to be equal to 0. That means this is included in our solution set. So use closed circles for -4 and 3 over 2. Again, at -4, we're going to use a closed circle. And at 3 over 2, we're going to use a closed circle. Now I have 3 intervals. I have to pick something to the left of -4, between -4 and 3 over 2, and to the right of 3 over 2. And we're going to find our test points in those intervals. Again, let's draw our number line. We have -4 and 3 over 2. These are going to be closed circles. Now let's pick some test points. What's a good number to the left of -4? I'm going to choose x equals -5. What's a good number between -4 and 3 over 2? Well, let's pick 0. I like to pick easy numbers, so let's pick x equals 0. What's a good number to the right of 3 over 2? Let's pick something easy. Let's pick x equals 2. That's going to be to the right of 3 over 2. So we'll test x equals -5 first in our inequality and see if it's true or false. We have 2 times -5 squared plus 5 times -5 minus 12. Is that greater than or equal to 0? This becomes 25 times 2, that's 50. 50 minus 25 minus 12, is that greater than or equal to 0? That's 13. 13 is greater than or equal to 0. This is true. So I'm going to have to shade everything to the left of -4. We'll shade everything to the left of -4. Now let's test x is equal to 0. So let's test x equals 0. We have 2 times 0 squared plus 5 times 0 minus 12. Is that greater than or equal to 0? Negative 12 is not greater than or equal to 0. This is false. So we do not shade between negative 4 and 3 over 2. Let's test one more. Let's test x is equal to 2. We have 2 squared plus 5 times 2 minus 12. Is that greater than or equal to 0? This is 4 plus 10 minus 12. Is that greater than or equal to 0? 4 plus 10 is 14. 14 minus 12 is 2. 2 is greater than or equal to 0. This is true. Since this is true, I'm going to have to shade to the right side of 3 over 2. Let's shade to the right side of 3 over 2. And now we could write our solution. Our solution is anything to the left side of negative 4. So that's going to be a parentheses, negative infinity, negative 4, square bracket. And that's going to be unioned with 3 over 2. And it's going to go to the right forever, so we're going to put to infinity. So this is our solution. It's from negative infinity to negative 4, union 3 over 2 to infinity. In example 7, if a projectile is launched from ground level with an initial velocity of 96 feet per second, its height s in feet t seconds after launching is given by the following equation. S equals negative 16t squared plus 96t. When will the projectile be greater than 80 feet above ground level? In this question, we're going to set negative 16t squared plus 96t greater than 80 because that's what we want. We want to figure out when our height is greater than 80. To solve this, we want a 0 on the right side, so let's subtract 80 to both sides of this inequality. This gives me negative 16t squared plus 96t minus 80 is greater than 0. I'm going to divide everything by negative 16 just to simplify this inequality. This gives us t squared minus 6t plus 5. Remember, we're going to have to switch the direction of the sign because we divided by a negative. So this will be less than 0. Don't forget to switch the direction of the sign. Now this factors as t minus 5 times t minus 1 is less than 0. Now I'm going to find my zeros. To find the zeros, we have t minus 5 times t minus 1 is equal to 0. We're finding the zeros first so we can fill in our number line. T minus 5 is equal to 0, or t minus 1 is equal to 0, which implies t could be equal to 5, or t could be equal to 1 is our zeros for this inequality. Now let's go to our number line and put 5 and 1 on our number line. But remember, look at this symbol here. This is a less than symbol. So we're going to leave it as an open circle. Do not use a closed circle at 5 and 1. We have an open circle at 1 and an open circle at 5. Recall our original inequality is negative 16t squared plus 96t is greater than 80. So we're going to have to pick a number to the left side of 1, and let's test x equals 0. We're going to pick a number between 1 and 5. I'm going to test x equals 2. And anything to the right of 5, let's test x equals 6. And we'll plug it into our inequality. So let's test x equals 0. I have negative 16 times 0 squared plus 96 times 0. Is that greater than 80? Well, 0 is not greater than 80. This is false. So I don't need a shade to the left of 1. Now let's test x equals 2. We have negative 16 times 2 squared plus 96 times 2. Is that greater than 80? That gives me 128 on the left. That is indeed greater than 80. This is true. So I should shade between 1 and 5. And now let's test to the right of 5, which is 6. So we'll plug in a 6 here. And we'll see if this is true. This gives me a 0 on the left. And that is not true. 0 is not greater than 80. This is false. So our solution is going to be between 1 and 5. So let's write down our answer. 1 to 5, parentheses around both of these, because we have open circles. So our solution is 1 to 5 in interval notation. Example 8, let's solve 5 over x plus 4 is greater than or equal to 1. Now I want you to notice that this is a 1 on the right side. It's very difficult to solve if this number is not a 0. I want a 0 on one side of the inequality. So let's subtract 1 to both sides of this inequality before we start. This gives me 5 over x plus 4 minus 1 is greater than or equal to 0. Now this is very similar to what we've been doing because the 0 is on the right side. Now I have a fraction here minus a whole number. So I'm going to change this 1 into a fraction and then try to get common denominators. Let's multiply x plus 4 to the top and to the bottom. This gives me 5 over x plus 4 negative x minus 4 over x plus 4. Now, I got the negative because of distribution here with the negative 1. This simplifies as 5 minus x minus 4 over x plus 4 since they have common denominators. Let's collect like terms. 5 minus 4 gives me 1. So this is 1 minus x over x plus 4 is greater than or equal to 0. Now after we simplify our inequality as 1 minus x over x plus 4 is greater than or equal to 0, I want to find my zeros. Now when is this inequality going to be equal to 0? Well, that's when the top is equal to 0. And so I could solve this for x. Let's add x to both sides. X is equal to 1. So that's when my inequality becomes 0, when x equals 1. Now, if I look at the denominator, I can also set that equal to 0. Subtract 4 to both sides. I have x equals negative 4. Now be careful. When the denominator is equal to 0, when we plug in a negative 4 for x, I get negative 4 plus 4 is 0. I cannot divide by 0. It's undefined when x equals negative 4. So when I draw my number line, I have x equals 1 is going to be a closed circle because that's when our equation is exactly equal to 0, and this is included because of the inequality with the equal sign underneath. So I'm going to shade x equals 1. But at negative 4, make sure you use an open circle. Why is this an open circle? Because it's undefined at negative 4. You cannot include negative 4 as a solution. 1 is included because of this symbol, greater than or equal. Negative 4 is not included because it's undefined. So anything that's undefined, make sure you use an open circle because it's not part of our solution. Again, we have an open circle at negative 4 because it's undefined there. We have a closed circle at 1 because it's included, it's greater than or equal. So make sure we have a closed circle at 1. Now I'm going to pick some test points. What's a good number to the left of negative 4? I'm going to test x equals negative 5. What's a good number between negative 4 and 1? We'll test x equals 0. That's a good, easy number to use. What's a good number to the right of 1? Let's test x equals 2. Again, you can pick any number in those regions as long as it's to the left of negative 4, between negative 4 and 1, and to the right of 1. So here's my test values. I tested negative 5 into the original equation. 5 divided by negative 5 plus 4. Is that greater than or equal to 1? Well, no, it's not true. Negative 5 is not greater than or equal to 1. That's false. We tested 0 in our original equation, and we found that 5 over 4 was greater than or equal to 1. That's true. Now, if you test 2, you'll realize it was false because 5 over 2 plus 4 is not greater than or equal to 1 because 5 over 6 is not greater than or equal to 1. So if you look at our region, let's go back to our region, we would shade only between negative 4 and 1. So what's our solution? It's going to be a parentheses for negative 4 because it's an open circle, and a square bracket for a 1 because it's a closed circle. So this is our solution for example 8, negative 4 to 1. In example 9, again, we want the 0 on the right. In this case, we have a 5, so let's subtract 5 to both sides. This simplifies to 2x minus 1 over 3x plus 4 minus 5 is less than 0. That's what I want. I want the 0 on the right side. It makes it easier to do the problem. So let's make this a fraction, negative 5 over 1. And let's multiply the top and bottom by 3x plus 4 now. This simplifies to 2x minus 1 over 3x plus 4. Now I can distribute that negative 5. And that's negative 15x minus 20 over 3x plus 4 is less than 0. Now, what can we do next? We can collect like terms for the top. That gives me 2x minus 15x, that's negative 13x. And then negative 1 and negative 20 is negative 21 over 3x plus 4 is less than 0. From here, now we could find our zeros. Remember, our zeros is when the numerator is equal to 0. So we'll set 13x or negative 13x minus 21 equals to 0. Negative 13x equals 21. And I have x is equal to negative 21 over 13 is a 0. Now, if you look at the denominator, it's going to be undefined. Again, when the bottom is equal to 0, it's undefined. When 3x plus 4 equals 0. And if you subtract 4 and divide by 3 on both sides, I get x equals negative 4/3. So it's undefined at x equals negative 4/3, and it's a 0 at negative 21 over 13. Again, one more time. It's 0 when the numerator is equal to 0, and it's undefined when the denominator is equal to 0. So be sure to check both the zeros and when it's undefined. we have 21 over 13 is an open circle. Why is this one an open circle? Because of the inequality, because of the less than symbol here. So it is an open circle. Negative 4 over 3. How come this one's an open circle? Well, because it's undefined. So there's two different reasons. This one's an open circle because of the symbol, the less than symbol. This one's an open circle because it's undefined. So let's pick some values to the left of negative 21 over 13. Let's pick some values between negative 21 over 13 and negative 4/3. And then we'll pick something to the right of negative 4/3. And we'll plug it back into our inequality to check if it's a true or false statement. I'm going to pick x equals negative 2 because that's to the left of negative 21 over 13. I'm going to pick x equals negative 1.5 because that's between negative 21 over 13 and negative 4/3. And I'm going to pick 0 because that's to the right of negative 4 over 3. So plug those numbers in to our original equation here and check to see if it's true or false. We'll test x equals negative 2 first. So I'm plugging in a negative 2 and let's see if it's true or false. We have negative 2 times 2, that's negative 4, minus 1, that's negative 5 on the top. Here it's negative 6 plus 4, that's negative 2. Is that less than 5? This becomes 5 over 2. Is that less than 5? Yes, it is. It is true. So I'm going to shade to the left side of negative 21 over 13. Let's plug in negative 1.5. I have 2 times negative 1.5 minus 1 over 3 times negative 1.5 plus 4. Is that less than 5? I have 8 on the left using a calculator. Is that less than 5? No, that's false. So don't shade between negative 21 over 13 and negative 4/3. One more test. We'll plug in a 0. Again, just use your calculators for these. It should be quick to test with a calculator. I have negative 1 on top. On the bottom we have 4. Is negative 1/4 less than 5? Yes, it is true. So I'm going to shade everything to the right of negative 4/3. And now we can state our solution in interval notation. My answer is negative infinity to negative 21 over 13. With the parentheses because this is an open circle, union negative 4/3 all the way to infinity, again parentheses around the negative 4/3 because it's an open circle, and parentheses around each of these infinities because infinities always have parentheses. So this is our solution, negative infinity to negative 21 over 13, union negative 4/3 to infinity.